Today I'm going to talk about section 9.2, and today we're going to talk about characteristics of quadratic functions or parabolas, and we're just basically building off of section 9.1. So the first characteristic that we can see is the different types of parabolas we can have. Now granted, these all open upwards. You can also have the ones that open downwards, but something's always going to take place, one of three situations when it comes to quadratic functions. You're either going to have a parabola that does not cross the x-axis, which would be no x-intercept. So what we would say there is there are no zeros of that function or no roots. So that we'll talk a little bit more about later. Or you'll have a quadratic that passes through the x-axis just once, and that's when the vertex is lying on top of your x-axis. So that would have one zero or one root, and then the other situation where we have two x-intercepts, which is two zeros or two roots. So when it comes to identifying roots or zeros, for the first one you would say none, because it has no roots or zeros. The second one, you could say it has one zero, but you'll actually identify where that zero is. So you could either say 2, 0, just actually label the point, which happens to be the vertex as well, or you could say 2. And then for the last one, the two roots lie at 1 and 3. So you could either say 1, 0, and 3, 0, or 1 and 3. So just two different ways to identify zeros or roots of a quadratic. Okay. All right, and what we can do with this concept is, again, talk about the axis of symmetry, and finding the axis of symmetry given a graph is very simple. If they give you a quadratic function that has two zeros, for instance, the one on the right here has two zeros, we can actually just add those. We can average those two together. So I would take 0 plus -4. And if we're averaging them, we're dividing that by 2. So that would be -4 divided by 2, which is -2. So our axis of symmetry is this line right here. And that tells me that my vertex lies on that line at the top. So that's what we use the axis of symmetry for, is to be able to identify a vertex. If they give you a function, for instance, I'm going to go back here. Let's say they give you one like this that only has one x-intercept or 1, 0. Your axis of symmetry is going to go through wherever that vertex is. So it's pretty easy to tell there. So that leaves us with the no zeros question. What if we're looking for the axis of symmetry and we don't have any zeros, or that the axis of symmetry is just hard to identify? In that case, we're going to go ahead and use a formula. And this works for every single quadratic function given an equation. And we'll talk more about this as well as the graphs and things like that as we keep building upon these concepts. But given an equation, there's a formula that we can use, and it goes like this: -b over 2a. And this is what we use to find the axis of symmetry given an equation. Okay, so what does that mean? Well, remember, quadratics are always set up like this: ax squared plus bx plus c, where a, b, and c are all numbers. So given the example or the equation that we have here, remember, if you don't see a number in front of a variable, there's a 1. So that tells me here that a is 1 and my b is -6. So using the formula, I would say I would have to plug in, I'm plugging in a negative for a negative variable, so what it looks like is -6 over 2 times 1. So really we have +6 over 2, which is 3. So our axis of symmetry is going to be at x equals 3. And this is where I should go back real quick and just remember, when we have a vertical line, the axis of symmetry of this one was at -2, and it is the x equals -2 line. So anytime you're asked to find the axis of symmetry, it's actually an equation. It's the x equals -2 line, or in our instance here, the x equals 3 line. It's just a vertical line that goes through 3. Alright, so one last concept. Sometimes they'll give us an equation, then they'll ask us to find the vertex. We're still going to have to use that formula because remember the vertex lies on the axis of symmetry. So -b over 2a. This is b. So that's going to be -12 over 2 times a, which is -3. So we have -12 over -6, which is 2. So my axis of symmetry is at x equals 2. And if my vertex is on that line, so let's say we know it's at x equals 2, okay? My vertex should be somewhere on this line. So all I have to do is plug in x equals 2 into our equation to figure out where the y location is. Okay, so that's what we're looking for here. So that's not our answer, it's just part of our answer. So I'm going to plug 2 in wherever we see an x to figure out our y position. So we do know this much. My vertex will be at 2 something. And we just plug in and do order of operations. So -3 times 2 to the second plus 12 times 2 plus 1. Remember, we do have to do exponents first, so I have to do 2 to the second, which is 2 times 2, which is 4. And then -3 times 4 gives me -12. Plus 12 times 2 is 24. And then plus 1. And then we are at subtraction and addition, so we just go left to right. So -12 plus 24 is 12. And then 12 plus 1 is 13. So our vertex lies at 213. And being able to find that vertex is a very important part, especially for the things that we're going to be talking about in the near future. So that is all I have for 9.2.